For centuries, we've looked toward the skies searching for answers. Places beyond our planet, as it's always been understood that there's more to life than what's seen here on Earth. And like everything else that stood beyond our understanding, technology granted us a seat at the table amongst the gods, trading worship for knowledge. And now when we look up, it's no longer with our eyes wide shut. The universe, seemingly infinite, has now been made smaller as information from the heavens above reside at our fingertips. Our sun, which was once believed to be a supreme deity, has been reduced to a product of complex chemistry and physics. There's a lot that we understand, but there's so much more that we don't. But the secrets of the universe are ours to discover. So let's take a look at what we found. I think we can all agree that there's something special to be said about a planet that's made of ice, yet always on fire. One could say that something this strange challenges our understanding of nature. One could also feel supported in their belief that anything is possible. Meet Gliese 436b, an exoplanet located within the zodiac constellation of Leo. Similar in size to Neptune, it's unique in such a way that its surface remains icy, in spite of its 800-degree surface temperature. Bizarre, right? You see, ice isn't only formed by freezing temperatures. Pressure can create ice as well. Under normal circumstances, colder temperatures decrease the motion of particles, and when this occurs in water, the molecules are able to bond together with very little motion, forming ice. However, when you apply a substantial amount of pressure, molecules have less space to move around, forcing them to form extremely tight bonds, creating ice, but of a different type not found here on Earth. Heat alone isn't enough to melt the ice found on Gliese 436b. And while the planet may not literally be on fire, the phenomena is enough to make you believe that God does indeed play dice with the universe. What is the point of life if you have no one to share it with? Here on Earth, we've become the apex, dominating the planet whilst also becoming its greatest cliche. 7 billion people, and yet we're lonely, galactically speaking. Let me explain. It's no secret that we're located in the Milky Way, which is home to billions of stars and planets, and yet we haven't found life anywhere else. And as it turns out, living within a supervoid doesn't help. The KBC void isn't just our home, it's a beacon of nothingness, a massive region of empty space spanning approximately 2 billion light years in diameter. While not completely empty, if you were to attempt to venture across it, you'd see absolutely nothing for over 100 million years. And with all the mathematical evidence stating that there should be an abundance of alien life within the universe, finding life within the KBC void would be like finding a needle in a galaxy-sized haystack. And it's unfortunate that we may be the tree that will fall and make a sound that no one will hear. We spend a lot of time asking questions that only stand to satisfy superficial ideas in an effort to protect our insecurities. One such question is, does size really matter? Maybe not to humanity, but for the rest of the universe, absolutely. Black holes take center stage when representing both the complexity and bizarre nature of the universe, and the existence of TON 618 does everything it can to make us feel inadequate. Its immensity is staggering, weighing in at 66 billion suns. It's large enough to engulf the entire solar system, and if it were in the Milky Way, it would have more mass than all of the known stars in the galaxy. Black holes force us to evaluate our perspectives in reference to the relationship between beauty and chaos. TON 618 is absolutely stunning, in spite of the chaos surrounding its nature. At the moment, it's considered a quasar as it's releasing massive amounts of energy into space due to the activity at its galactic nucleus. While TON 618 isn't the gentle giant we may want it to be, I'm just happy that we're able to admire its beauty from 10 billion light years away. I've been wondering, what is the most expensive thing in the world? Well, whatever it is, I'm sure it wouldn't be as valuable as a star with a core made of diamond. BPM 37093, better known as Lucy, is perhaps the most expensive object in the universe. For reference, the Cullinan diamond, the largest diamond on Earth, is just over 3,000 carats. Well, Lucy, with a diameter of approximately 2,500 miles, is about 10 billion trillion carats. And for additional reference, that is a 1 with 34 zeros behind it. If we were to come into possession of such a diamond, diamonds would immediately lose their value as they'd become the most plentiful resource on the planet. But what if I told you that a diamond slightly smaller than Lucy's existed within our very own solar system? Well, I'd be lying. Technically. You see, in about 5 billion years, the sun will eventually die and become what's known as a white dwarf, and its core will begin to crystallize into a diamond. While it's great that this will happen eventually, so close to home, it's unfortunate that humanity may not be around to see it. They say that you cannot help who you are attracted to, and it's been proven that the laws of attraction scale far beyond humanity. We are bound by the laws of physics, and the law states that whomever holds the most mass shall have the most influence. There's been an ongoing mystery dating back as far as the 1970s, where it was discovered that our galaxy was traveling in a specific direction alongside other galaxies in our galactic neighborhood. And it was determined that all galaxies in our local cluster were moving toward a specific point. This could only mean one thing, that something extraordinarily abundant in mass was pulling everything toward it. And we call it the Great Attractor. The Great Attractor is mysterious in the way that it's obscured by our own galaxy, meaning that we can't see what it is as the contents of the Milky Way hinder our view. Gravity determines the path that an object takes as it falls toward a more massive one, and we're falling toward the Great Attractor at speeds at over 1.3 million miles per hour. But even at such a high speed, we wouldn't reach the Great Attractor for billions of years, which seems like great news, until we notice that the Great Attractor itself is being pulled by something more massive than it, perhaps proving that nature knows no bounds.